So what we're going to deal with is ACLs. So once again, anytime you get into an environment, what you want to do is inspect the IP scheme. Are they using sub interfaces? Are they using VLANs? Are they using a public or are they using a private IP address? So those are things we want to investigate. And there's lots of notes all over this. So I'm just going to go into the router, command line. I see database full, so it's using, so that should be right there, OSPF. That's a layer 3 routing protocol. So we got RIP and EIGRP. So Cisco class password. So let's see what the configuration is first. So we can do a show start, but we don't know if someone's configured or made changes. So we want to do show run, which is a running memory. Host name, enable secrets encrypted. Here's our IP address for FA00 and also serial. So we want to recognize the subnet mask of 255.255.0. So make sure that any device, in this area is going to have the same subnet mask. Default gateway is the router interface, default gateway. And then your serial has got a 252-bit mask, increments of 4. So 0 is the network, 1 is the IP. I can assume router 1 will have the next IP of 2. 3 is my broadcast. And then we have an IP access list extended. I'm sorry, we just go back here to the routing. So we're using OSPF. You're not expected to know that tonight, only expected to know that it's a routing protocol layer 3. And then also some of the characteristics of it's intensive with the CPU, it's most complex, it grows with the network. Those things that we covered in that chapter. So we have IP access list extended, implicit. Okay, so this is a extended ACL, which is beyond the scope of what we're doing. But we're going to work with these because when we do our final exam, it'll be easier, much easier. Permit TCP, that would be layer 4. Any, which also can be written as 255, 255, 255, 255.0 because ones are ignores. So any source to any destination. So we're permitting through equal to port number 44. So this is its own access list. Over here, we have a second access list. It's an extended, and it also is named enterprise. We're going to permit TCP, and here's our wildcard mask. It's the opposite of the subnet mask. So if we just do the math with 255s, so opposite of 0 would be 255, opposite of 0 is 255, opposite of 0 is 255, opposite of 255 would be 0. And then we're going to another network. So that's the 192.168.10 is the network address. And it's addressing the wildcard mask of 0.0.0.255 equal to domain. So that would be DNS, port 53. And then we are also, depending on the application, DNS can use TCP and UDP. So we want to permit to make sure these hosts, assuming these is a 172 network, then we go to the next line, same network, same wildcard. We're saying to the individual host. So if you remember from Monday, host is also 0.0.0.0. Zeros are exact matches. So host can replace that. as a wildcard, and we're saying to this server. So we're only allowing web browsing through port 80. Once again, then we're limiting to this server port 80. So only 101 with the IP address of 101 will be able to reach the server. 192.168.1.101 is the requesting, and then the 172 is going to be the server. So you see how we have both IPs in here, but they're intermittent. So 100 is allowed to do secure web browsing. And then we have 101 is allowed to do FTP, the program, and also 101. So remember, FTP has two ports, ports 20 and 21. Okay, those should be things that you should be able to identify now. And also we're going to, only 102 is allowed to do email once we apply the ACL. So we're going to see some things work and then fail. So this router, let's go into the config. I'm doing show run because it's the most current, because if somebody made changes to the running config and didn't save it, then it would still be the run. So we have IP address, a fast Ethernet, we have a serial 252.2. So that's, we could have predicted that just by looking at command line in router 0. And then we have OSPF, and then we have no ACL. So let's test some services. So it looks like we're using domain. So we should be able to come into this PC, go to the web browser, type in the domain name. So rpm.org. Now remember, it's probably going through an ARP. It's probably trying to get through the network. It may time out the first time. So that's what's going on. So let's look at the encapsulation of the data. So let's go ahead and do the same process. We'll use a different PC because I want to see the ARP and things like that happen. So rpm.org. There's my ARP. I have an IP. I don't know the MAC address. Layer 2 broadcast FFF. Goes into the switch. Goes out all interfaces as a broadcast and comes back with DNS server. So that's the IP, and now we have a MAC address. So now it's trying to get to the DNS server. It finds the DNS server. Now I'm going to get a TCP. So now we're at port 80 because I'm trying to do web browsing. And we know that that's going to bring up the web page. So there it is. Let's go through this process because we're going to skip the ARP because we've already gone to and got the DNS entry. So we have that in our NIC card, layer 2. So now we're just requesting DNS with no ARP. And if we look at the requests, port 53. So we need to identify those important port numbers and also the application that belongs to it. So now it's coming back with DNS. So let's test ping. So this PC here, we haven't done any activity, so we know that it's not in the CAM table in the switch, right? So if I ping the IP, I'm going to skip DNS. So let's do that first. Ping 192. So that's the IP of the server. Once again, ARP because we know the IP, we don't have a MAC address. What happens is the router says use my MAC address. Now we're pinging. Remember, ICMP only tests layers 1, 2, and 3. No application layers. So successful ping. Email. So if we look at the server, just a quick look at the services running. HTTP is on and HTTPS is on. DHCP is off. Same as the HTTP v6. TFTP is on, DNS is on, and we have these. Notice that I have an HTTPS in there for secure web browsing. Syslog is on. We'll cover some of these other concepts. That would be your network time protocol. Email, so we do have email set up. And we also have FTP on. So we can test those services. We'll do email next. Go to your client, go to your email. We'll just reply here to tmihawk. As you know, I'm a man of few words. So go to tmihawk, he's going to check the email. So let's delete these. Receive. There it is. Thanks. So we'll reply, but we'll see what's going on in the layer process. So we want to focus in on port number. So let's reply. Evidently, S. Caldwell's a few words more than me. So TCP, let's look at the IP protocol stack. We see layer 4, TCP. Remember, that's the three-way handshake. And using port number 25, which is the POP protocol. So we'll let it advance. Leaves our local network, finds the email server. And so that's how you see the reply. FTP, so we'll stay in this client and we'll FTP to server 0. So if you type FTP, you get a usage. So it's FTP, then the target. We're going to use the IP address. So admin's not it, so I'm going to do my history command. I'm going to try Cisco. All right, so you can see there's a failed attempt with the username password, and we have a correct attempt. So FTP is working. We'll exit. Quit. So let's go to simulation and see the same process with FTP. So FTP to target. We should see layer 4, port number 21. So this is actually the application data, not the FTP program. Port 20 is the program, port 21 would be the application data. We can see it reaches the server. And once again, port 21. So that's your FTP service. So SMTP and POP. So we saw, let's do we sent the sent, we didn't do the receive. So let's reply to T-Mihawk. Get more wordy. So turn simulation on. Email client. Receive. So we look at it's using port 110. So if you remember when we were using the send, it was using port 25. So depending on whether you're doing a send or receive, the port numbers will change. So the services are all running. So what we're going to do now is apply the ACL, and then we're going to test the services and what works and what doesn't. So remember, when we write the ACL, we want to write it in Notepad. Use numbers, because if we want to adjust I could do 11 and then I could do a permit or deny statement to fix something. So oftentimes you want to adjust and add lines to your ACL, because in a big organization, they're going to buy applications and they're going to say, oh, it's going through this port number. Open this one and open that one. So a firewall is constantly being asked to do different things. So you want to leave room with these numbered. So if you want to insert something that doesn't affect something down the line. So remember, sequential, line by line. But if you don't number them, you have to pretty much start from scratch. So since we're using extended, remember, extended should be closest to the source, ES. And if you're using standard, it's closest to the destination. So all these ACLs are referring to the 172 network. So that's the source. The destination is here. So we're going to put the ACL on fast Ethernet 00, and we're going to do IP access group enterprise out. So once you define the ACL, so we wrote the access list here. So it's sitting here. So now we have to apply to the interface. So config T, interfaces. So it's IP access group enterprise out. So let's test the first domain. So anybody in the network of 192.168.1.0 should be able to resolve DNS. So we'll test PC. So dsrpm.org. So doesn't work for IP address 102. So if we look at it should be working, right? There it goes. Remember that you got to wait for the network latency. So go to this PC. All these are encompassed in the 192.168.1 dot. And once again, DNS for this PC will work also. So DNS is working. So we don't know what's not working. So let's test web browser only from 100. So let's test web browsing to 100. We just tested So any PC will be able to get into port 80 and 443 because of these statements here with the permit equal to WW101 and also, so everybody can get to 100, but it looks like we're going to limit only the PC 101 to get to 101's website. So they all went to, so let's see if we can get to so this is IP address 102 and it won't go to the website 101. So let's test IP address 102. And according to the ACL, it should permit or deny. Should deny. So the only, so if we look at the 172.168.1.100, and only host 100, which is right here, should be able to access the website. So a good example would be like you are a vendor coming into a corporate environment and can only access that website that other people couldn't, only because your IP address. Okay, so the ACL looks like it's working. We should be able to FTP only to 100 from host 101. So if we go to host 101, we should be able to FTP into 100. Okay, it gave me a username, so I know that's going to work. Now let's go to IP address 102, and let's try to access FTP. So this PC is not allowed because of the ACL. So FTP is only allowed by 172.16.101 to 192.168.100. Email, which was working for everyone, will only work for 172.16.102 to the server. So when we send an email from 102 to 101, so let's send an email. Prediction is, so let's just go ahead and reply to that Army Hawk is 100. So ACL test. So let's go to check email. Let's delete these, not to confuse ourselves. Receive. So you see that it's not working. It did work. We know that. So the ACL is actually working properly. But now we've kind of made a little bit of a pickle because only the 102 host, this S. Caldwell, can send receive, but no one else can. So all the mail goes to the server, sits there, and we call people and go, why don't you get my email? So let's take the ACL off. So if we remember the command, that's IP access group on the interface. And now let's go ahead and see if we can receive that email. And there it is. So that's how ACLs work